All right, this is the third part to this set of 5.5 notes. So we will be wrapping up these notes today. So the last set of formulas that I want to share with you are these sum to product formulas. So of course, sum means add, product means multiply. So you can rewrite either a sign plus a sign, sign minus a sign, or similar with the cosines. I can rewrite an addition statement using multiplication. Okay, and then we can also use that to, again, find exact values for a variety of angles. Okay, so if we want to find the exact value of cosine of 195 degrees plus cosine of 105. Okay, so we're just going to follow the same equation. So cosine u plus cosine v equals 2 times the cosine of u plus v over 2 times cosine of u minus v over 2. So again, the angle v is this first angle 195 degrees, and then angle v is going to be the cosine of 105. Okay, so to rewrite this, we would be saying the cosine of 195 degrees plus the cosine of 105 degrees is 2 times the cosine of u plus v. So 195 plus 105 divided by 2 times the cosine of 195 minus 105 divided by 2. All right, so when you add these, notice what happens. So we have the cosine 195 plus 105 is 300. So this becomes 300 divided by 2. And cosine, when you subtract, is 90 divided by 2. So being able to rewrite this as a product is really going to be beneficial for us, because now we're looking for the cosine of a 150 degree angle and the cosine of a 45 degree angle. And those angles I have on my unit circle, and I can find the sine or the cosine of each of them. So cosine of 150 degrees is a negative root 3 over 2, and cosine of 45 is a root 2 over 2. So multiply together, you get negative 2 square root 6 over 4, or that would reduce to a negative root 6 over 2. All right, so since I couldn't do the cosine of 195 degrees and the cosine of a 105 degree on its own, because those aren't on my unit circle, by being able to rewrite them as products, I was actually able to find the exact value. Okay, these last two examples are verify. So this kind of takes us back to the second section of this chapter, where you were working, you could work on one side or the other, or you actually could manipulate both sides at the same time, and to get this to be to verify that this is a true statement. Okay, so we're going to use the sum to product rules in these, and I'll show you how that's going to work in just a minute. Okay, so if I have sine b plus cosine b quantity squared, well, so write that out. So you're going to have, excuse me, a binomial times a binomial. So you're going to distribute or FOIL. And first, you get a sine squared beta outsides plus a sine beta cosine beta. Insides is going to be a cosine beta times sine beta. and last are going to be a cosine squared beta. Okay, we do have like terms here. So I have sine squared beta plus 2 sine beta cosine beta plus cosine squared beta. Okay, well, if you notice here, look, I have a sine squared and a cosine squared, so that should be familiar to you with the Pythagorean identity. So I can make a substitution for sine squared plus cosine squared is 1, and then 1 plus 2 sine beta cosine beta. Okay, now remember where we're heading is 1 plus sine 2 beta. So since we want to get to that sine 2 beta, that's one of those double angle formulas. Grab your formula sheet, and if you look back at what that is, so I'm just going to write it down here for you. So sine 2 beta, that double angle formula is 2 sine beta cosine beta. Okay, so that's your sine 2 beta. Well, if you notice, this is exactly what I have here. Okay, so I'm going to be able to make this substitution. So 2 sine beta cosine beta is the same as the sine of 2 beta. And that is what we're trying to show that it is equal to. Okay, so same thing we've done before. It's just now that you have at your disposal many trig equations that you can pull from. Okay, so let's look at example 10, cosine of pi over 2 minus x, and we want to show that that's going to be equal to sine of x. All right, well, cosine of pi over 2 minus x, so what are you doing here? You are subtracting two angles. So if you go back to your sum and difference formulas, you have the cosine, the difference formula. So I'm just going to jot it over here. So cosine of u minus v is cosine u times cosine v plus sine u times sine v. Okay, so that's what we're going to use, and we're going to plug in your pi over 2 for your v, for your u, and then x is going to be the v. So cosine of u minus v is cosine of u, so pi over 2, times cosine of v, which is x, plus sine of u, pi over 2, times sine of v, which is x. Okay, so cosine of pi over 2, so that's a 90-degree angle. Cosine is your x coordinate. So cosine of pi over 2 is 0 times cosine of x plus the sine of pi over 2 is 1 times sine of x. Well, 0 times cosine x, that's just 0, plus 1 sine x, or sine x equals sine x. Okay, and that finishes this lesson, and it also wraps up this chapter.